Advent of Code, day 22. Okay. So, okay. Um, yeah. Bit slow, but now we need to do this a billion times, right? What? Bananas. Consecutive changes. This is most. Okay. This is complicated. Um. Oh. Okay. 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 So. Okay. So I've got that. Um. I've got. Okay. Um. I'm gonna just brute force it. Um. B minus A. That. Um. I guess actually looking for deltas. Do I even need that? Probably not useful. Oh, and then we have what? 19 for. That's not too bad. Okay, so um ooh, yeah. So actually, yeah, I think I do want that actually. Um, at this point, then 4, yeah, yeah, we'll do that. I've got more trust in that. This actually might. Where did I do append? Where did I do append? Yep. Okay. There are faster ways to do this, but I prefer brute force here. This is not the best brute force. I really hope I don't have a bug. If I do, oh, if P is none, continue. Glad I read that. Crud. That is taking so much longer. Okay. That is taking forever. Let's just see if my code is correct. So we have Okay. Then 224. Oops. Is 9. Okay. Great. Great. Okay. So that's fine. Um. Uh. Yeah. Mm-hmm. I'm doing that. You can just be that. I do want this. I don't need last. Um, yeah, that's so slow. Okay. Um, and then find match. Eh, Um, you're supposed to be brick. Okay. And then these look good. 9. 9 is correct. Okay. So then we actually instead do this. You know what? Yeah, we do that. Because then we can leverage it. I don't care about you. Okay. I could have been a little faster there, but at least I was a lot faster than yesterday. Um, yeah, brute force is not the way to go for part two. Not at all. There's, see, I don't need that anymore or that because I don't use it. And sure, okay. Yeah, a lot of this probably can be done actually faster than what I did, just runtime wise. Oh, right. Um, yeah. So let's talk about this. Uh, so we have a random number generator, which actually takes me back to. Oh, this takes me back to day 22 of my first year, I do believe. 2019, day 22. Yeah, spoiler alert. This problem was a roundabout description of a random number generator, which was quite interesting. Um, in part two took me something like 5 hours to do. I really liked that problem. And this is also a good problem. This one actually calls out that it's a pseudo-random problem. Day 22 of 2019 was just an RNG just hiding there. So yeah, part one is just generate the RNG sequence and code these rules and get those rules running. So yeah, I mean that's what this is. This could be compressed, but these are just those rules up there. And then just run it 2,000 times in and get the 2,000th yeah 2,000th number for each of the input seeds in the input, and just sum them up. So that's not too bad. Not too much code at all. Then part two is where we get interesting, where we're taking that RNG, uh, we're then taking just the last digit of those 2,000 numbers, and looking at that as a price history. Now, the initial approach I was doing, which was a very crude brute force, was just take a list of every. Well, I guess actually, before even talking about that, once we've got this price history, then we need to look at the deltas, the changes, as the price history evolves, and then look for a given sequence of deltas. And that sequence of deltas then is what a monkey is looking for to then buy a banana. So yeah, taking that information, the brute force approach I was trying to do was just get the seller prices, get all the deltas, and enumerate every single potential delta list, and just check each sequence of prices against each delta list, and try and get the answer that way. That will eventually get the answer, but you are doing so much redundant computation. You're doing kind of similar computation to what I'm doing here. In this, we already see it takes, so it's what, 2, 3, 4, 5, like 5 or 6 seconds. The problem is we have to walk through all of those price lists for every single delta change sequence. Now, some of them we can return early because we then would have found a banana to buy. But if we don't find one, we'll have all the numbers from -9 up through 9 uh, possible for each position in the delta list. So we are actually going to have 19 to the fourth possibility. So we would have to wait that like 5 to 6 seconds, 130,000 times. Let's be optimistic. Let's say that we half the time find a match in a price list. We're not going to find it that often, but let's just be optimistic. That is going to take 108 hours, or about 4 days, about 4.5 days even. So yeah, brute force it would complete eventually, but I don't want to let it run that long. So instead, and this is really what I should have done in the first place, and what I was almost considering doing, but then I talked myself out of it before talking myself back into it. Construct the full list of deltas up front, and then at each position, just at each potential point where we might be able to sell a banana, calculate what the most recent 4 deltas have been. This here is just an early return because I didn't want to spend time thinking about getting the range right. But take the at each position, I get the deltas for that position, convert that into a key, as well as get the price that we would sell if that's the key, the delta sequence we're looking for, and store that in a map. Now we do need to only do this for the first time we see that sequence. So just a quick if check there. But once we have that, we can actually construct a map directly in one single pass for the entire prices of every single delta sequence that we might be looking for. So once we do that, the really nice thing about Python collections.counter is you can add them together. And under the hood, it's going to actually then, for the base map here and the map you're adding into it, for any keys that match, it's just going to take the values and add them together. So I don't have to do any complex looping or anything like that. I just run this through, and then we're actually going to have a single map of all the sequences to how much we would get. And once that's done, we can just take the max of the values, and that's our answer. So really a much more straightforward problem than yesterday. I'm curious. Took 20 and a half minutes. I arguably should have been faster. How much did I miss? Ooh, I missed by a lot. So yeah, even if I were faster, I don't think I would have been that fast. For part one, I was about 4 minutes. Yeah. Ooh, Jonathan Paulson got it. Got part one. Jonathan Paulson types way faster than I do. Um, and I'm looking at the times up here. I'm not surprised to see him not there. Yeah, Neil Thistle, the other guy I typically look for, not even seeing him at all. Um, in one other name, I think it's TCK. I'm not seeing him either. So yeah, this was surprisingly easy for a weekend problem this late in the event. I'm suspecting this is just a break before we get a couple more hard ones. So yeah, I'm, as I've said in the last few, I am sad to still have no leaderboard points here. I've got a few more days left to try and get them. So here's to hoping. I would really like this to not be the first event I get no points in, but we will see. One other thing, which I was going to mention yesterday, but I forgot, as I was looking at this page yesterday, preparing for the problem, I noticed not only do we have the very blatant 10 here, but we have AOC 10 years here, just in ASCII. So that's a nice little message to see in the overall calendar page. So yeah, we'll see this complete in a few more days. But until then, I've got a few more days of problems to try and get leaderboard points. So we'll see how that goes. But that's all I got. So I'll be back tomorrow.